Okay, guys, so today we are going to totally switch gears with this new chapter, and we're going to start talking about scale factors and similar figures. Um, so today's just kind of a real quick overview of um, similar figures, how to enlarge something, how to make it smaller. If you've heard of scale drawings, or like a lot of times you'll see like the Empire State Building, and then they have a mini of the Empire State Building. It's all the same dimensions. So we're going to talk about kind of what that means, that idea. So we're going to talk about what dilations are. You guys talked about transformations last year. You guys did reflections, rotations. Oh, there's another one in there. Transformation. So moving things left, right, up, down, rotating it 90 degrees, reflecting it over a certain line. Now we're going to talk about dilation, so when things get bigger or smaller. So along with that, we're going to talk about what's called the scale factor, and then types of dilations, and then kind of go from there finding measures of things. So at the top of your notes, you see that you have three characteristics of a dilation. First thing, all sides are proportionally larger or smaller by a scale factor. You guys, last year in Math 1, you did a lot of congruent figure work, like proving triangles congruent by side, 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 side angle, side. We're going to do that same idea, but now it's similar. So they're not the same size, but they're all proportionally bigger or smaller. Orientation does not change, which means you're not flipping it and moving it around. It's not the reflections or rotations you talked about last year. You're simply changing the size. Then angles are all still congruent. So you're going to hear a few words a lot. The original image is called the pre-image. Okay. And then the image, so this is like your start right here, is your pre-image. The image is your ending figure. So we call that, and we call it an image, but you'll hear a lot of the word prime. So if you look in this picture over here, the green figure, notice it's just A, B, C. This right here would be my pre-image. And the reason I know that, sorry, apparently I can't write on this today. The reason I know that is because if you look at the purplish figure, see how it says A with an apostrophe? We call that A prime, B prime, C prime. So because these have the primes, which are, they look like apostrophes, that makes this my image. Okay, so in this case, it started as the green figure and was dilated to the purple figure. Okay, now you have a couple different types of dilations, just like last year when you could rotate 90 degrees, 180 degrees, 270 degrees, so on and so forth. You have a couple different types of dilations. You're either going to have an enlargement, a reduction, or a congruency transformation. Now, an enlargement means that you're going to hear what I refer to as K. Oh, it's up here. Sorry. I knew I lost it somewhere. Your scale factor determines what your dilation is. And what that means is the scale factor is going to tell you how much bigger the figure is going to get or how much smaller it's going to get from the pre-image. So if that scale factor is a K value, because it's kind of like, you know how we call slope M? We call scale factor K. If K is greater than 1, then it's an enlargement, and your pre-image is going to get bigger when it goes to the image. If it's a reduction, your K value is between 0 and 1. So that, notice you don't have any negatives, because a negative would insinuate a reflection, which you kind of talked about last year, or a rotation. So we're just focusing on positive. So it's either going to get bigger if K is bigger than 1, smaller if it's between 0 and 1, and then obviously if you have a congruency transformation, then K is equal to 1. And you guys, you don't see this a lot. It literally just means that your shape isn't changing size. So it's kind of silly, like you wouldn't do a dilation where it doesn't change size, but there is technically a name for it. To find scale factor, to find your K value, you are always going to do prime divided by the original. That's going to kind of be how I refer to it. So if I wanted you to find scale factor of something, so let's look at this picture that we have up here. To find the scale factor of this, if you look, we have AB, which is 15, and we have A prime, B prime, which is 10. So those are kind of like a pair. Okay, and then you have BC, which is 12. I'm going to underline it because it's a different pair, and B prime, C prime, which is 8. To find my scale factor, I'm going to do prime over original. So the K value of this would be, and it does not matter which pair you pick. You just need to pick one that's a pair. So my prime would be 10. My original would be 15, which means my K value, sorry, when reduced is 2/3. So what that means, you guys, is because the green's my pre-image, the image is 2/3 the size of the original pre-image. Okay. If I had chosen to go with 8 and 12, it should always work out to be the same scale factor if you do it correctly. So I could have done 8 divided by 12, which we also know reduces to 2/3. Obviously, you can kind of tell from the picture, but the scale factor confirms the fact that it's a reduction because 2/3 falls between 0 and 1. Okay. All right, so we're going to kind of play around with that a little bit today. These first two say determine if the following are dilations based on the characteristics above. If they are, find the scale factor and determine the type of dilation. So is it a reduction, is it an enlargement, or a congruency transformation? So if you look here, we're looking at our points. This is D, this is D prime. Okay, well point D is at -2, 2. Point D prime is at -4, -4. Well, if I take point D, to get it to be D prime, I had to multiply it by 2. -2 times 2 is -4. 2 times 2 is 4. So then you want to check and make sure that that's consistent across the board. So then look at E to E prime. I have to multiply my X and my Y by 2. 2 times 2 is 4. 1 times 2 is 2. So that also works out. And F to F prime, same idea. 2 times 2 is 4. -2 times 2 is -4. So every single point, D, E, and F, to get from the original to the prime point, I took not only the X but also the Y, and I multiplied both of those by the exact same number. So in this case, that number was 2. So that tells me that, yes, they're a dilation. Sorry. Here we go again. Yes, they're a dilation. And my K value, or my scale factor, is 2. Okay. Now remember, there were a couple other characteristics at the top of our notes. So orientation does not change. We just check the scale factor. All of our coordinates check out. Here, orientation doesn't change. It is the exact same orientation. We haven't flipped it, moved it, whatever. And my angles are congruent. Here they're marked, so we're good. So this is a enlargement because K is bigger than 1. Okay, so you could say that, yeah, this is an enlargement and that the image is 2 times bigger than the pre-image. Okay, it's twice as large. Now, one way of looking at it is the coordinates, which you could do on number 2. But for number 2, I want to look at it a second way as well. If you look, it's kind of hard to see. Hopefully you can see it a little bit more on your picture, on your notes. But this is one of our pictures. That's our prime, actually. And our original is this size. Okay. Well, here in number 1, we did coordinates. Up here with our example, we looked at side lengths. I'm going to take the side lengths approach here because I can nicely do it since it's a rectangle. So this side is 5. This side is 5. And this side is 6, and so is this side. So that's the yellow. Of my green, this side is also 5. This side is also 5. But this side is now 9 units long, and this side is 9 units long. So if you look, every single side, so if you look at the first bullet point, it says all side lengths are proportionally larger or smaller. Well, my horizontal sides got smaller, 9/6, right? So if I look at my vertical, they didn't change at all. So in this case, it's not a dilation because you can't just change part of your figure and not all of the sides. So in this case, no, it's not a dilation. Okay. So literally every single side would have to change by the same amount in order for that to be a dilation. Okay. All right. The only difference now is in 3, 4, and 5, it says, yes, they are dilations. So we know they are. And we want to find the scale factor of each and determine the type. Okay, so this is kind of like the example at the top. I'm going to look, A to B is 10. A prime to B prime is 5. A to C is 12. A prime to C prime is 6. So again, you only need one pair, but you want to make sure to do prime over original. So my K value here, let's pick the bottom pair. Let's do AC. Why not? My prime is 6, and my original is 12. So my K value is 1/2. Okay? So because it's 1/2, it's a reduction. Okay. And I'm just going to write out a quick sentence to formalize this a little. Okay? So what we know is triangle A prime, B prime, C prime. So our image where we ended, because it has the primes, is half the size of triangle ABC, which was our pre-image. Okay, so that's kind of how to formalize that. That's what that really means in words. If you look at number 4, again, we are now given 3 side lengths in both triangles. So AB, maybe, let's try this here. AB, there we go, is a pair with A prime, B prime. AC is with A prime, C prime, and notice I kind of do different things, and then BC and B prime, C prime, especially just because as we get into this, it's going to be harder to keep them all together. So again, the problem's already telling us that yes, it's a dilation. So you don't need to check all 3 pairs. If you want to make sure you're good to go, you can, but you just need to pick one. So to find our K value, we're going to do prime over original. So let's just go with our circles. I'm going to do 10 as A prime, B prime over 2.5. Okay, so if you do 10 over 2.5, you get 4. So your K value here is 4, which means this is an enlargement. Okay. And the formal way of writing it is triangle A prime, B prime, C prime is 4 times larger than triangle ABC. Okay. All right. Our last one. Now we're just dealing with points. Okay. So we kind of did that up in number 1. It says point A is at 412 and point A prime is at 618. What's the scale factor? Okay. So I would think of this as XY and this as X prime, Y prime. So you guys, it's the same thing as the figures before. It doesn't matter what point you choose, just pick one and it will work out. So to find your K, you're going to do prime over original. So in this case, if we do our X's, X prime is 6 and X is 4, which reduces to 3/2 or 1.5. Obviously, it doesn't matter. So if K is 3/2 or 1.5, that means it's an enlargement. Okay, so in this case, whatever figure this would be a part of, right? You won't just dilate a point. This would be part of a figure. That figure would end up being 1.5 times bigger than the original. Okay? All right, on to the back, we're just going to do a little bit more practice with scale factors. Now, we're going to be given one length in the scale factor and find the final length, or some version thereof. It says if AB has a length of 3 units and is dilated by a scale factor of 2.25, what's the length of A prime, B prime? So you guys, it's the exact same thing we just did on the front, okay? If A prime, B prime is what we're looking for, we're going to take its original, which is 3, and we need to multiply it by our K value, 2.25. So A prime, B prime, in this case, sorry, obviously my computer hates me, that's nothing new, is 6.75 units. Okay, again, you guys, units are going to come back strong in here, so don't leave them off. All right, for number 7, it says, what are the side lengths of D prime, E prime, F prime with a scale factor of K equals 2.5, and then they give you DE is 1 centimeter, EF is 9.2, and FD is 8.6. Sorry, I missed the second half of this question over here. Is it a reduction, enlargement, or congruency transformation? Well, in this case, they give us our K value of 2.25, so it has to be an enlargement. Sorry, I ran out of room. Okay, so that segment got bigger by 2.25 times its size. All right, for number 7, let's see, we're going to take DE, and to find D prime, E prime, we're going to take 1 and multiply it by our 2.5. So that becomes 2.5. Sorry, my handwriting is so horrendous right now. Centimeters is our units there. Okay, E prime, F prime. You're going to take your 9.2 of the pre-image, multiply it by your scale factor, and you get 23 centimeters. Okay, and then for F prime, D prime, you're going to take the original 8.6 measurement and multiply it by your K value of 2.5, and the final image would be 21.5 centimeters. So obviously, because our scale factor is 2.5, this is an enlargement. Okay, so that final figure would be 2.5 times bigger than the original. All right, for number 8, it says, what are the endpoints? Now notice this is slightly different. It says, what are the endpoints of G double prime, F double prime, if G is located at 8, -3, and F is located at -5, 2. And the segment is dilated by a value of K equals 1.4. Okay, so you guys, all that means, and you might have seen this in Math 1 last year, is that we're dilating it twice. So the double prime means do it twice. So if we start with point G is at 8, -3. To find G double prime, I'm going to take that 8 and I'm going to multiply it by 1.4, but then I'm going to multiply it by 1.4 again. Okay, so let me clean that up a little bit. I'll write out the process. Let's do this. Sorry. Okay. You do not need to show this work. You could go straight to G double prime, but if you wanted to find G prime, you would do 8 times 1.4, which would get you 11.2, and -3 times 1.4, which is -4.2. So that's when you multiply by your scale factor once. But we want G double prime, so now you're going to take those prime points and you're going to multiply it one more time. So 11.2 times 1.4 is 15.68. And what is it? -4.2 times 1.4 again is -5.88. So that is your final G double prime point. So we multiplied by 1.4 to get here, multiplied by 1.4 to get there. Multiplied by 1.4 here, multiplied by 1.4 here. Okay, obviously, hopefully some of you are thinking, hey, isn't that just 1.4 squared because I'm multiplying by 1.4 twice? You are right, it totally is, and yes, you can do that. So F is at -5, 2. I'm going to show a little less work on this one, you guys. So F double prime, if you multiply -5 by 1.4 and then multiply it by 1.4 again, you're going to end up at -9.8. If you multiply 2 by 1.4, multiply that by 1.4 again, you end up at 3.92. So those are your 2 prime points. Obviously, that is an enlargement because it's a K value bigger than 1. All right, the last thing we're going to do is a triangle has vertices at A, B, or A, C, and J. Okay, so they give you the coordinates. If the triangle is dilated by a scale factor of K equals 0.5, what are the image vertices? Is it a reduction, enlargement, or congruency transformation? And then draw in the pre-image and the image and label appropriately. So let's graph these points and label it. You guys, labeling is super important with these. A is at 2, -3, so we're here. Okay. C is at -6, 2. And J is at 0, 4. So this is my pre-image. Whoops, not 4. Let's try J on for size. There we go. All right, so it looks like, wow, I am killing it today, guys. All right, looks like this. Sorry about the bell. So that's your pre-image. Now, it says we have a scale factor of 0.5. So I'm going to take all of those coordinates and multiply them all by 0.5. So to find A prime, I'm going to take 2 and I'm going to multiply it by 0.5 and I get 1. -3 times 0.5 is -1.5. So we are at 1, -1.5. Make sure you label that as a prime. C started at -6.2. So if you multiply that by 0.5, -6 times 0.5 is -3. 2 times 0.5 is 1. So we're at the point -3, 1, and you're going to label it as C prime. And then J prime started at 0.4. 0 times 0.4 is still 0. 4 times 0.5 is 2. So we're here, and that's J prime. So there's your image and your pre-image. So the pre-image is the purple, the image is the green. And then, is it a reduction, enlargement, or congruency transformation? Well, we can tell from our scale factor that it's going to be a reduction, and the picture verifies that because it got smaller. Okay? Notice it's the same picture, it just got smaller. It didn't turn, it didn't flip, nothing like that. So all things that you can use to check your work. Okay? All right, cool. You can spend the rest of the period working on your homework. It probably shouldn't take you too long. If you're spending a good amount of time on this, something's wrong. Come see me and I'll help you. Okay? Thanks.